Okay, ji, Assalamu alaikum. I welcome you all back to the regular lectures, right? We are having a lecture after a break of about 2 weeks, right? So this is the 13th week of the semester. It means that we are left with around 4 weeks, okay? So since we are meeting after a break, so I'll first recall you that what we have been doing recently, and then I will link it to the current topic, that is polymorphism, right? So let's get started for today. Okay, so if you remember in the previous weeks, we have been talking about inheritance, right? So we said in inheritance, basically the idea is that you should be able to reuse the classes which you have already designed, right? So if you remember that we had done many examples, right? But maybe we had done say an example where you have a class called student, okay, which is called a parent class, and then you can have one or more child classes, right? For example, I can say a UG student or a PG student, and we represent inheritance by an arrow which is pointing from the child class to the parent class, right? So the idea is that whatever attributes a student has, for example, name or enrollment number or GPA, right? They are inherited by the child class. So you do not need to rewrite them again, right? So all the data as well as member attributes of the parent class, they are inherited by the child class. And then of course, child class can have its own data as well as its own functions as well, okay? So the idea is that whatever is common in UG students and PG students, you will put them in the parent class, right? So that you do not have to repeat it two times in both the classes. And whatever are the specific features of say UG student or PG student, you will put them in their specific classes, right? So this is what we had been doing, right? And then we had seen another concept maybe in the last lecture, that was called function overriding. Okay, and I told you that it is again a very typical interview question, that when you appear for an interview, people would ask you what is function overriding, or they might ask you what is the difference between function overriding and function overloading, right? So function overriding is actually related with inheritance. You cannot have function overriding without inheritance, right? And the idea was that if you have say a parent class, right? Let's call it base. It has some function, say f, okay, and then you have a child class which is inheriting from this, and within this class you again make another function f with exactly the same name, same return type, and same arguments, right? Nothing should be different, means it is exactly the same function as you have in the parent class, right? So now you see this child class is inheriting f from the parent, but it also has its own f, right? So this concept is called function overriding. In other words, you can say that this child class is saying, I don't need your f function, I will create my own f function, right? And in order to understand this idea, I had given you an example that suppose someone is giving you a car, right? But you say, no, I don't need your car. I have my own car like that, so I will use it. Okay, so you are actually overriding the offer. You are not accepting this. You are saying, I don't need it. I will use my own car, right? Similarly, the same idea is here. This child is inheriting function f from the parent, but it says, no, I don't need your f. Okay, what I will do, I will create my own f. Okay, and this is only possible when this function has exactly the same name, same arguments, as well as same return type, right? So this was the idea of function overriding that we had seen. And why we were looking at it, because this function overriding is actually linked with the topic that we'll see today. Okay, so I was just building a preamble so that you actually things are refreshed in your mind before we start today's topic. And both inheritance as well as function overriding will be used in today's topic, which is actually polymorphism. Okay, so this is actually one of the most important features of object-oriented programming, right, which is supported by many languages like C++ as well as Java, right? And as I keep telling you that there are some core topics of object-oriented programming, and it is one of them, right? So when we started our discussion, composition was a core topic. Then we had operator overloading, right? So these are the two topics normally we see in the first half of the semester. Then in the second half, you have two core topics. One is inheritance, and the second one is polymorphism, which is actually related with inheritance as well, right? So now let's see what polymorphism is. So as always, first I will explain to you conceptually without writing any program, and then we'll be writing some programs. Okay, so polymorphism, if you translate it, right, so poly actually means many, right? Multiple, many, whatever you want to call it, right? And this part morphism actually comes from morphology, right? And morphology means form or shape or structure or anything that you would like to call it, right? So if we make an effort to word by word translate polymorphism, so a rough translation could be like many forms, right? This is a, you can say, approximate translation of this word polymorphism. Now, it is true, many forms, but many forms of what, right? So in order to understand polymorphism, let's go back. We have already seen something similar to polymorphism, right? And what was that? Maybe, okay, let me just divide it, right? So we had seen already a type of polymorphism, which is actually called static polymorphism, which was function overloading. Okay, I'll explain why I am calling it or relating it with polymorphism. If you remember function overloading, what happens? You have same function, means name of the function is same, but the arguments are different, right? So you can have an add function, which is adding two integers, and you can have an add function, which is adding two real numbers like float. Okay. So now you see it is add, which is the same function, but it is behaving differently. This one is the one on the top, it is adding two integers. The second one is adding two real numbers, right? But it's the same function. So it means this function has two forms, right? Two, when we say many forms or multiple forms. So in this case, this function has two forms. One is adding two integers, the other is adding two float, right? So this function overloading is actually somehow related to polymorphism, but it is called a static polymorphism, right? Today we'll see the other branch. Okay. Now, within this, you also have another related concept which you have seen, which you can relate with polymorphism, is operator overloading. So you see what is operator overloading? You define that what an operator will do. For example, if it is a plus operator, if you are adding points, it will behave differently because you have overloaded it to add 2 points. You recently did an assignment on rational numbers, right? So when you are adding rational numbers, they are added differently because you have to take an LCM and then simplify the fraction or whatever you do it, right? So you see the operator is the same, but it has now different forms. Similarly, if you are adding two integers, x plus y, they are added differently, right? So here you are adding 2 points, a plus b, to rational number or two integers or any other class. And similarly, you have also seen that this operator works for string as well. If you write s1 plus s2, both the strings are concatenated. So you see, it is the same operator which is plus, but it has many forms, right? So you again see, we can relate it with the same concept of polymorphism, because the behavior of this plus is different depending upon you are using it with what. If you are using it with the integers, it has a different behavior. Sorry, if you are using it with rational numbers, point or circle or string, then every time it will have a different behavior, right? So you can also relate it with this terminology, many forms, right? So now if we come back to our discussion from where we started, let me just make it a bit cleaner so that you can easily get the idea. So we started with something which is called polymorphism. If we translate it, we said it simply means many forms, right? We have already seen some type of polymorphism, which technically is called static polymorphism, in which we have seen function overloading, right? Because in function overloading, functions have many forms. So this is true. And the second similar thing we had seen is called operator overloading, because in operator overloading as well, your operator has many forms depending upon what class objects you are using. The behavior of an operator would be different, right? So this is the part that you have already seen, but we never called it polymorphism, right? We did not use this terminology, but now since we are maturing, so we are looking at it from that perspective. You already know what is function overloading. You already know what is operator overloading. The only new thing is that we have given it a specific name that we call it many forms, means different behaviors, different ways of implementation, right? And we are calling it static polymorphism. What we'll see today is this second branch, okay, which is new for you, which is called dynamic or runtime polymorphism. Why we call it runtime or dynamic, you will see, you will be convinced when I write a program, right? So for the time being, we can stick with this terminology, but this terminology will become clear once I write a program, okay? And within that, what we'll see today is basically a new concept which is called virtual functions, right? So this is the overall you can say tree, which tells that these are the two concepts which we have already seen. And for today, we'll see polymorphism, but more specifically, it is runtime or dynamic polymorphism, in which we'll see virtual functions, right? Now, basically, how this will work. Before writing a program, let me just give you an example. That suppose you have different pet animals, okay? And of course, if you're writing a program, this can be a class, pet animal, right? It could be anything, name of the animal could be data member, or you can say whatever you want to call it, okay? And suppose you have different pets at your home, like maybe you have a cat, you have a duck, and you have a parrot. Okay, so since all of these are pet animals, so if you try to write a program for it, so it means that you can make pet animal a parent class, and since inheritance is a relationship, so you can make them child classes, right? Because if a cat is a pet animal, duck is a pet animal, parrot is a pet animal, so whatever attributes pet animals have, cat, duck, and parrot, they all have same attributes, right? Okay, now what we do is that, suppose this is you, okay, and you have these three pets, okay? So when you give a command to your pet animals, right? For example, you get a command speak, and by command it means you are calling a function, right? So you see, cat has a different voice, duck has a different voice, parrot has a different voice. But you will only give one command speak, okay, means you will call one function. And of course, cat will behave differently because cat has a different sound, right? I don't know, maybe it will be like a mew. Duck has a different sound like quack, right? And similarly, parrot had some other sound. So the idea of polymorphism is that you will be giving one command, right? Like for example, you are saying speak to your pet animals, and everyone will behave differently. Why differently? Because every animal has a different sound, right? So this is the idea of polymorphism. Of course, we have not written any program, so don't be confused. I'm just explaining you from the real world that you give one command, okay, and depending upon the type of the animal, the behavior would be different. You are asking animals to speak, so every animal has a different sound, so they will speak differently, right? Similarly, you have given them some food, right? So what will happen? You will give a command eat. Okay, so every animal would be eating a different food, right? Because they do not have exactly the same feed. So the idea is that you will call one function, right? If we now relate it with programming, you will call one function, but what will happen? The behavior of the function will be different for every child class, right? Because these cat, duck, and parrot, they are child classes. You ask them to talk, so everyone will talk in their own language, right? But you don't give three different commands, right? The whole idea is that you just give one command to everyone talk, and everyone starts talking in their own language. So rather than first asking the cat to talk, duck to talk, parrot to talk, in which you will have to give three different commands, right? This is the general idea. Now let's see this with the example that is more related with you can say programming. So suppose you have a parent class which is shape, okay, and then you have two child classes. The first child class is circle, right? and the second child class is a rectangle. Both are shapes, right? So you can easily do inheritance here, right? Now suppose you give a command draw. Okay, so what should happen if you are giving command to both of these? So if it's a circle, a circle should be drawn, right? If it's a rectangle, this should be drawn. So the idea is that you will give only one command draw to both of the child classes, and if the class is circle, it will draw a circle. If the class is rectangle, it will draw a rectangle. Now you see you are calling the same function, but the behavior is different. Just like I had given you the example of animals, you are calling draw, but if you are calling draw of circle, it will be drawing a circle. If you are calling draw of rectangle, it will be drawing a rectangle. So now you relate it with many forms. When we say many forms, now you should understand that I am calling the same function, but the behavior is different. If I am calling the function with rectangle, it will be drawing a rectangle. If I'm calling this function for circle, it will be drawing a circle. So the name of the function is same, okay, but the behavior or the output is different depending upon what I want to draw, right? So this is the general idea. You can we have seen two examples, one with animals, the other one with shape, and now is the time that we actually write some programs so that we can convince ourselves and we can correlate this discussion with the program, right? So let me just gain some space and write a very simple program, right? So of course, when you are doing polymorphism, you will always be doing inheritance, right? Polymorphism is not possible without inheritance. Similarly, whenever you are doing polymorphism, you will always be doing function overriding, right? Why will we be doing that? Let me write a program and then we discuss. Okay. So let me make a class. Say we call it. This is our parent class. We call it say base. I'm not having any data in this class. I'm just making a function. Okay. So we simply make a function void show, right? And within this we can write C out base class show function, right? Or whatever you want to write. And here we conclude our class. Okay. Now what we'll do is let me make another class, right? We call it child maybe. So and in order to make base a parent, we put single colon public base, right? Just to remind you the syntax because it's been 2 weeks we have not seen it. Okay, so now what I do uh, when I make this class child, it is inheriting this show function from the parent. Means this show function comes here, it becomes a part of the child class, right? But this child class says I don't need your show function, I will make my own show function, right? So you can make a show function in this child class. This is actually function overriding, which I told you. Okay, you see the name of the function is exactly same, return type is void, there are no arguments, right? If you change it, then it will not be function overriding, then it will be function overloading. For example, if you change the arguments, then it is not function overriding, right? The arguments, the name, as well as the return type all have to be exactly the same. So now within this I write C out and we end the class here. Okay, so now we have simply one parent class, one child class. Parent class has a show function and the child class is overriding that function. Okay, so nothing much, fairly simple things. Okay, now what we do is that suppose this is our main program. Now in the main, you know that if you make an object of base class and you call the show function, okay, so naturally what will happen, the show function of this base class, it means you will see base on the screen, this will be called, right? So the output would be base. Similarly, if you make an object of child class, child C, okay, and then you call the show function. Now you see child class has two show functions. One is inherited from the parent, which is this one, and the other one it has overridden, right? So what will happen when you will write C dot show, it will not call the show function of the parent class, it will call the show function of the child class. Why? Because you have done function overriding. When you override the function, this child class is saying to its parent, I don't need your show function. I will have my own show function, right? So the output in this case would be, sorry, child. Okay. So this was actually function overriding. Okay, which is straightforward. If you have a base class object, you will see the base class show function being called, and if you have a child class object, you will see the child class function being called, right? So it was pretty straightforward. Now let's slightly change this main, right, and let's do something more challenging. Okay, now what I do is that just for the sake of discussion, I make a global function. Okay, this is not inside in any class. Maybe I just make a function. Okay, and this function is accepting an object of base class. Okay, this is an important discussion, so I would request your attention. And here I am simply writing b dot show. Okay, means whatever was previously happening in the main, instead of doing it in the main, what we have done, we have made a function. We pass it base class object and we call b dot show, right? Previously, this statement was written in the main. The only difference is now I have written it inside a function. Okay. Now let me write main and let's discuss something. Okay. So if I write say base b and I call this function f, then again nothing will change. Okay. What will happen? This b will go to this b. You will call b dot show. So you will see base printed on the screen. Right? Means it is exactly the same thing. We have just made a different function, right? But why we are doing it now? Let me just write something else. Okay. Now instead of making an object of base class, let's say I make an object of child class. Okay. And when I call this function, I pass it C. Okay. Now you see this is important, so please pay attention. The function requires an object of parent class, but what I am doing, I am passing it an object of child class, right? So the first thing that you might be thinking is whether this is legal or not, right? Now this will need some discussion, so let's discuss something. Okay, you know, inheritance is a relationship. Okay, it means every object of child class is also an object of parent class, right? Every UG student is also a student, right? Every car is also a vehicle. Okay, so if you have classes like vehicle is a class, car is a class, so every car is also a vehicle. So when you make an object of car, it is an object of car, but it is also a vehicle, right? Now let's say that this is some auditorium, right, and in which there is some event going on. Okay, and the condition of this event is that only registered students can attend this event, right? Only students can attend. Means no one from outside the university is allowed to enter this auditorium. Only students can attend, right? So if students can attend, and so you have student class and you have two types of student, UG as well as PG. So when I say students are allowed, it means UG students are also allowed, PG students are also allowed, because both are student, right? When you are allowing the student, so it means every type of student is allowed, right? In the university, if you have two types of student like computer science student, management science student, since every computer science student is also a student, child class, right? Every management science student is also a student. So if we say students are allowed, then all types of students are allowed, right? Now let's see the same thing with a different example, right? Just to convince you, because this is something important that we'll be reusing in our subsequent discussions. Okay, so let's now take an example where we say that okay, we are maybe building a bridge or a motorway, right? So this is a you can say motorway, and this is the entrance of the motorway, right, or the bridge, whatever you call it, right? So you see, we make some condition that pedestrians are not allowed on the motorway, right? Similarly, two-wheel like bikes are not allowed, but vehicles are allowed. Okay, so on this bridge or on this road or on this motorway, people cannot walk, means pedestrian are not allowed. Two-wheelers are not allowed, means bicycles or motorbikes, they are not allowed, but vehicles are allowed. So if vehicles are allowed, then it means cars are also allowed, trucks are also allowed, right? Jeeps are also allowed because they are also all types of vehicle. So if I'm saying vehicles can cross this bridge, it means car is also a vehicle, so car can cross a bridge. Truck is also a vehicle, jeep is also a vehicle, they can cross the bridge, right? But pedestrian cannot cross the bridge because a pedestrian is not a vehicle, right? So with these two examples, now let's come back to our previous example, right? That suppose there is a function which requires an object of say student, right? So this is a function f. You can see it like this is an auditorium in which event is going on, okay, and this function requires student as an input. Now from the main, if I make an object of UG student, u, so you see UG student is also a student, it is a child class of student. So if I call this function, if I'm passing it u, it is perfectly legal. Why is it legal? Because this function needs a student, I am passing it a UG student, but every UG student is a student. We know that, right? So that's why this is a legal statement. Okay, you can relate this code with that auditorium example in which only students are allowed, right? So it's exactly the same thing, but instead of an auditorium, we have a function, right? And instead of a gate or a door, we have this function argument, right? So in other words, the summary of this discussion is every object of child class is also an object of parent class. Every car is a vehicle. Every UG student is a student. So if somewhere I'm expecting or I'm allowing a student, then it means every type of student is allowed. In other words, every object of child class is allowed. Okay. So now with that discussion, if we come here, so the same thing is being done in the second column of this board, right? This is a parent class like student, and this is a child class like UG student. This function needs a student as an input or the parent class. I'm passing it child class, which is like a UG student. So this is perfectly legal code, right? It will not give you any error. It will work perfectly fine. Now, the thing is that now which function will be called? Okay, because you see, what is the type of B? Base. But what I am passing? An object of child class. And we say that this C will be copied in B. This is perfectly legal, right? But now the next question arises that when you write B dot show, whether this show function of the parent class will be called or the show function of the child class will be called, right? So the answer is that when you are calling this function, it will not see what you are passing as an argument. It will see the data type of B, right? What is the data type of B? The data type of B is base. Okay. So when what will happen is that it will call the show function of the base class, right? Because it will not see what you are passing as an argument. It will only see, okay, this is B. What is the data type of B? Data type of B is base. So it will go to the base class and it will call the show function of the base class. So the output of this would be, you will see this base on the screen, which is the output, right? So maybe I can quickly make this program and show you the output so that you are convinced, right? And then we can discuss things. Okay. So I don't have Visual Studio today due to some problems, so I'll be using an online compiler, right? But I hope it will work. Okay, so let me quickly make the class. Okay, uh, just two classes. So let me call it class base. Within this class, we make a function void show. Okay, and within this function, I simply write cout base class show function. Nothing much, and that's it. Okay, so this is our base class which we discussed a little while back. Now you can make another class which is a child, and you make it a child of the base class or the parent class, whatever you want to call it. And within this, what you do function overriding. Okay, so I will make a function void show, and here I will write child class show function. Okay, and first we convince ourselves that what will happen if we make object. So I make an object of base class, I call b dot show. Okay, similarly I make an object of child class and I call c dot show, right? So this is the easier case, right, in which B dot show should be calling the show function of the parent class. C dot show must be calling the show function of the child class, right? So I'll try run it if it compiles, right? So you see, I hope you can see the output at the bottom of the screen, where this statement B dot show, it is giving you output base class show function. Similarly, you have C dot show, which is giving you child class show function. Okay, so now what we can do is we can change this. So I can make a function just like we did when we were discussing. Okay, so maybe I can write void function and base B. Okay, and here I can write B dot show. Okay, so in the main, instead of making an object of base class, I make an object of child class and I pass it to the function. Okay, so now you see the function is expecting, say, a student as an input, and we are passing it a UG student, which is legal, right? The first thing is that you should be convinced this is legal. And when you will write b dot show, so it will not see what you are passing as an argument, it will see the data type of b. The data type of b is base, so it will actually call the base class show function, right? So you can run this program and convince yourself. So you see this is the output. You can see at the bottom of the screen it is saying base class show function. In other words, it is calling the show function of the base class, right? So of course, we have not moved to polymorphism yet, right? This is just a preamble that we are building, right? But till here, if you have any comments or queries, please let me know so that we can discuss further. Thank you. Okay, now we'll be extending the same example, right? But now we'll be introducing polymorphism. So what I will be changing is that uh, instead of having one child class, I will be having a parent class, okay? And we'll be having two child classes, right? Because you see, only then polymorphism would be meaningful when we have one parent class and at least two child classes, right? Okay, now let me just make the parent class. The parent class is exactly the same as it was previously, right? So I'll just quickly rewrite it. But the thing that will be changing is that now we'll be having two child classes, okay? So again, public void, and here we'll be writing the same thing, okay? Since this is our first example, so we are just writing C out, okay? But naturally, when we'll be doing some different examples, we'll be doing something else, not C out only, okay? So now this is parent. Now we'll be making two child classes, right? So I'll name them, say, child one and child two. So this is, say, child one. And I will be simply overriding that function. Okay, so I'll be writing void show, and here we'll be writing cout um, child one. Okay, so now we have one parent class, one child class. This is what you just looked at. But now what we'll be extending is that I'll be making a second child class of the same parent class, right? So we'll be writing, say, class child 2. Okay, again, the parent is same, which is base class. Okay, and within the body, what we do? Not much. We simply do exactly the same thing. We override the show function. And within the body, I simply write child 2, and we end the function, we end the class. Okay. Okay, now let's write main. Okay, but now we'll be writing slightly different main. Okay, so if I visually show you through class diagram, so this is your base class. Okay, and then you have child 1, you have child 2. Both of these are child classes, and base class is the parent class. So I show inheritance by an arrow which is pointing from child to base, right? Base class has show function, and both the child classes are overriding this function, right? Means you child class 1 has overridden show function, child class 2 has also overridden show function, right? So the only new thing in this example is that instead of having one child class, we now have two child classes. Okay. Now you see, we'll not make direct object, but now we'll do something different, right? We say instead of taking an object, we take a pointer to the base class. Okay, because we can take a pointer just like we take an object, so there's no problem with that. And at the same time, I make an object of, say, child 1, we call it C1. Okay. So this is a pointer, and this is an object of child class. Okay. Rather, let me first make an object of parent class, right? Not child class. We go stepwise so that you understand it well. Okay. So I have a pointer to the base class. I can make an object of base class like this, and you know very well that we can do this. P is address of B, right? Means I can copy the address of this object in this pointer. And you also know that now if you have to call some function with pointer, instead of dot, you use arrow, right? So if you want to call the show function with P, you will write P arrow show. But if you want to call it with B, which is object, you will use dot, right? So this is something we discussed many times, right? I asked many of you in the Viva as well that when you have to call the function with object, you use dot. But when you have to call the function with a pointer, you use this indirection or the arrow operator, right? So this is straightforward. We have base class pointer, we copy the address, we call the functions, right? But now we'll be slightly changing it, right? And what is it that will be changing? That instead of making an object of base class, I'll be making an object of child class, right? So say child 1, we call it C1. And now this is the important part. What we'll do this thing. Okay, now you see all the examples that I had given you were for this particular statement, that the pointer is of base class, but the address that I am copying in it is of child class. Now, at first sight, you might think that this is not legal, right? This is not allowed. But now just relate this with the examples that I had shown you, that every object of child class is an object of base class, right? So it means on the left side, for example, if you have student, right? And on the right side, if you have UG student. So this is perfectly legal because every UG student is also a student, right? Similarly, on the left side, if you have a vehicle, on the right side, if you have a car, so this is perfectly legal because car is also a vehicle, right? So of course you cannot do it other way around, that on the left side you have child and on the right side you have base, then you will have problem. But let's not discuss it for the time being, we'll discuss it later on. So you see, on the left side I have student, and on the right side I have a UG student, but we also know that every UG student is also a student, so that's why this is a perfectly legal statement, right? So the key idea when we are doing polymorphism is that we'll always do, we will take pointer to the parent class. Okay, this is something that you will always do in every example with polymorphism. The pointer would be of parent class, but you will be copying in it the address of child class. Okay, and this is a perfectly legal statement, thanks to all those examples that we have seen. You can also do the same thing for child 2, right? For example, you can now make another object, say child C2, sorry, the class is child 2, the object is C2. So this, if you write P gets the address of C2, this is again a perfectly legal statement, right? Because child 2 is also a child class of base, right? So both of these are legal statement, right? So in other words, you can copy the address of a child class object in a pointer to the parent class. This is the whole, this statement is the summary of whole of this discussion, right? That if you have a pointer to the base class, it is perfectly legal to copy address of a child class, right? Okay, but now the thing is that now you must be thinking that what will happen if I call this show function now, right? Because P is of type base, but the address in P is of child 1, right? So now whether the show function of the parent is called or the show function of the child is called, right? And similarly, after this, okay, you can also do something like child C2, and you can write P gets the address of C2, and then you write P arrow show. Okay. So now we have to focus on these statements, right? Let me just change the color. Now we are focusing on this and this. Okay. Now you see here, P is having address of C1. C1 is an object of child 1. So when I write P arrow show, which function will it call? Will it call function of the parent class or the child class? And the same discussion is on this. Okay, both are actually the same discussion. So the answer to this is that in the current form, as you see the program on your screen, your program will not see what is the address in P. It will simply see the data type of P. Okay, just like we discussed a little while back. What is the data type of P? Base. So what will happen? It will, this statement which you see on the left side, it will call the show function of the base class. And what is on the right, again it will call the show function of the base class. Why is it happening like that? Because in this case your program is not looking at the address which is in P. Okay, it is simply looking at the data type of P. Since P is a pointer to base, so whether P is having address of C1 or C2, in both of these cases, this statement which I am highlighting, P arrow show, okay, both of these are giving you the same output, which is base. So if you run this program, you will see base on the screen. Okay, although in the first case P is having address of C1, in the second case P is having address of C2, and C1 and C2 are two different classes. But in both the cases, the program is not looking at the address which is in P, it is only looking at the data type which is in P, and the data type of P is base. So what will happen is that it will simply call the show function of the base class. It will not call the show function of the child class, right? So this is what is happening in the current form, right? Now you see this is not very useful, because if we are calling the um, we can call the show function of the parent class using the parent class object, right? So what we want, which is not happening, what we actually want is that this statement should call the show function of child 1, and the second statement should call the show function of child 2, right? So in other words, what we desire is that instead of looking at the data type of P, if somehow your program can look at the contents of P, right? That if P has address of C1, then this statement should call show function of child 1. If P has contents of C2 or address of C2, then this statement should call, you can say, show function of child 2, right? So if you are able to do that, okay, then this is polymorphism. Why is it polymorphism? Because we have the same statement, P arrow show here and P arrow show here. But this one, which is on the left side, it will be printing child 1, and the one on the right side will be printing child 2. So in order to achieve this, okay, now this is something new, so please pay attention. What we need to do is we need to make this function a virtual function in the parent class, right? So there's a keyword called virtual. There's a keyword called virtual. So you simply add a keyword virtual here, right? In the parent class, not in the child classes, okay? So when you make this function virtual in the parent class, what will happen now? Now, when you write P arrow show, your program will not see the data type of P, it will see the contents of P. If P is having address of C1, it will call the show function of C1. If P is having address of C2, it will call the show function of C2. Right? So it is a lot of information, I understand, but I'll repeat it many times. Don't worry, I'll write the complete program. Let me give you a summary and then write the program, and then I'll repeat it with many more examples, right? So the new thing we have seen here is a virtual function. Virtual is a keyword in C++ as well as in Java, right? So what you do is that when you want to do polymorphism, you make a function in the parent class, okay? And you make it virtual by adding the keyword virtual with it. Okay, this is the first thing you will do. Then what you will do, you will override that function in each of the child classes. We have two child classes. So I'm overriding the show function in child class 1 as well as child class. Okay, so the first thing you need to do for inheritance is you need to have a parent class, you need to have at least 2 child classes, and then you need to have a virtual function in the parent class, which you will be overriding in each of the child class. Now, when you come to the main, what you will do, you will take a pointer to the parent class, which we did like p, and then now you are allowed to copy the address of any of the child classes. So you can copy address of c1, you can copy address of c2, right? And when you call the show function with the syntax p arrow show, so if the show function was virtual in parent class, what it will do, it will not see the data type of p, it will see what is the address in p. If P is having address of C1, it will call the show function of C1, which is child 1. If P is having address of an object of class child 2, then it will be calling the show function of child 2, right? Now let me make this program first without a virtual function and then with a virtual function, and then we'll see and we'll convince ourselves that this actually works. Okay, so I'll make exactly the same program. Okay, so we already have this base class. Instead of calling it child, I will simply change it to child 1, right? And here I will write, say, child 1 show function. Okay, now we don't need this anymore, this function, this discussion is over. So let me get rid of this. Yeah, now what we'll do, I'll make another child class, right? So I'll write class child 2 public base. Okay, now within this child class, what I will do, I will again override the show function, and here I will write child 2 show function. Okay, now you have one parent class which is base. It has a show function, but for the time being I have not made it virtual. Okay, we have one class which is child 1, which is derived from the base class. It also is overriding the show function. We have another child class which we are calling child 2, again derived from the parent class. Now in the main, what I do, I take a pointer to the base class. Okay, and I take first an object of child 1, which is c1. Okay, and what we do in this, we copy address of c1. So you see, this is a perfectly legal statement, because in a pointer to the parent class we are allowed to copy the address of the child class. And now I will call p arrow show. Okay, so what we did, we take a pointer to the base class, we make an object of child 1 and we copy its address in p and we write p arrow show, right? Similarly, I will do the same thing for child 2. So I write child 2, we make an object c2 and we write p gets the address of c2, right? And then I call the function p arrow show. Okay, now you see, we have these classes, show function in the parent class, show function in every child class. We take a pointer to the parent class, only then polymorphism will make sense, right? And first we copy address of c1 and then we copy address of c2, right? So now if we run this program, what will happen is that in both of these statements, you see p arrow show, p arrow show. If you see the output at the bottom of the screen, you see base class show function. It means both of these are calling the show function of the parent class. Why? Because they are not looking at the contents of P. They are simply looking at the data type of P. Since P is a pointer to base class, so whether you write P arrow show here or here, in the first case, it has address of C1. In the second case, it has address of C2. But both of these are actually calling the same function, which is the show function of the parent class. So as I told you, now what we'll do is we'll go back to the parent class, and with this function, we'll add a keyword which is called virtual. Okay, so this virtual function actually is telling your program that when you see P arrow show, you don't have to see the data type of P, you have to see the contents of P. When P is having address of C1, you will call show function of child 1. When P is having address of C2, you will be calling the show function of child 2, right? So now simply I did nothing. I simply made this a virtual function. Rest of the code is exactly the same. Now if you see the output, you see at the bottom of the screen, Now the first statement, which is p arrow show, it is calling child1 show function. Why? Because p was having address of c1. Now similarly, if you see the second statement, p arrow show, it is calling child2 show function. Why? Because p was having address of c2. Now you see, this is actually, now if you relate it with the discussion from where we started our lecture, that a function has many forms, a function has different behaviors. Now you see, I'm writing the same statement, p arrow show. If you see this statement, okay, which you see here, which is printing child1, and the other statement which is here, right, which is printing like child2. Okay, so both of the statements are actually the same, p arrow show, but here it is printing something else, right, child1, and here it is printing something else. So you see, the same statement or the same function call is giving you different results. Why? Because now your program is looking at the contents of p. If p has address of c1, it is calling the show function of that class. If p has address of c2, it is calling show function of that class, right? And so on. You can have more than two child classes as well. Okay. Now you relate it with the animal example or the draw example, right? You can have parent class, which is pet animal. Then you can have two classes, cat and duck. Okay. And there is a function speak or talk. So when you will write p arrow speak, okay, so if p has address of a duck, the speak function of duck is called, or if p has the address of cat, then the talk or the speak function of cat is called, right? This is one example of polymorphism, right? We'll do many more, right? But till now, if there are any comments, please let me know, then we do some more examples of polymorphism. Thank you. Okay, now this is the same example. Let me just show you back again, right? That this is the example that we were doing, but now I'll be slightly changing this example, right? You see, I have taken a pointer p. In that same pointer, first I'm copying the address of c1 and then c2, right? So instead of doing that, what we can do is that I can take two pointers, right? So one way of taking two pointers is I can write base pointer p1, base pointer p2, right? These are two pointers. But you see, what if I need 10 pointers or 100 pointers? Then I cannot define 100 different variables, p1, p2, p3 up to p100, right? So we have a facility which is called an array, right? So what is this? This is an array of two pointers, right? The first pointer is p0 and the second pointer is p1. Okay, so sorry, like this, p1. So now you see, the advantage of an array is that I don't need to declare two different variables. Okay, in this case it is 2, but even if it is 20, I just need to write 20 here. Now these are 20 pointers. Rather than writing p1, p2, p3 up to p20, I can define 20 variables in just one line. Okay, so this is the advantage of having an array. So just like you define an array of integers int a2, since we are defining an array of pointers. So previously it was like this, base pointer p. This syntax you already know. If instead of one pointer you need 10 pointers, you simply put a square bracket and 10. Now these are 10 pointers. Okay, so now let's do it with two pointers because we only have two objects. So what I do is that I make an object of child class c1, and in the first pointer I copy its address. p0 gets the address of c1. Okay, and similarly, what we do is in the second pointer, which is p1, I can copy the address of c2. Sorry, there you go. Okay, so in p0 I have address of c1, and in p2 I have address of c2, which is an object of child class 2. Okay, similarly, if you want to create more objects, you can repeat this process, right? And you can copy the addresses in the pointer. Now what I can do, I can write a for loop for, I am doing with a for loop because presently I only have two pointers, but this program will work even if you have 100 pointers, right? Now you see, what I can do is I can write p of I arrow show. Now this is actually the important statement. Okay, when I is 0, p of 0 has address of c1. So this statement will print child 1 on the screen. When the loop executes for the second time, I is 1. Okay, so P of 1 is having address of C2, so it will print child 2 on the screen. Now you see the advantage. Now I don't need to worry that in what order the objects are created. Let me just make it 4. Okay, so I say C1, C2, and then I make another object of child 1. We call it C1A. I make another object of child 1. We call it C1B. Okay, now I can copy these addresses. Okay, now you see the first pointer is holding address of C1. So this statement, when I is 0, it will print child 1. When I is 1, it will print child 2. When I is 2, it will again print child 1. And similarly for the last one, it will again print child 1 because we are creating an object of child 1, right? So now you see this statement, this function call is actually explaining you that when we say many forms or when we say polymorphism. So what does it mean? That I am writing the same statement, P of I arrow show, but every time or it depending upon what address is in PI, it is giving you a different output, right? So this actually statement illustrates the concept of polymorphism. Okay. Now let me just add one more thing to this and then maybe we can move to a different example. I'm going back to 2 pointers only, okay? And I'm changing but to back to 2. Okay, so now we have only 2 pointers. Okay, now you see I first create object of child 1, child 2, and then I copy its address in the pointer. So you see later on C1 and C2 are never used, right? Because whenever I have to call the function, I'll be calling with P, because if I don't call with P, then the whole idea of polymorphism is lost. In polymorphism we make a pointer to the base class, and we using that pointer we call the function. Only then polymorphism will work, right? So in other words, the objects C1 and C2 that I am making, they are never used again in the program, right? Because I simply copy their address in pointer, and then throughout the program, whenever I have to call a function, I am calling it through pointer. So if you remember, in the beginning of the semester, we discussed that instead of first creating an object and then copying the address, we have something which is called dynamic memory allocation, right? Where you write the keyword new and then you can write the name of the class. So what will happen with this? It will create an object of child 1 and it will copy it at its address in P0. Similarly, the second statement, which I have highlighted, if you write new child 2, it will create an object of class child 2 without any name. Okay, we are not giving it any name. And the address of that object will be in P1, right? So previously, first we were creating object and then we were copying address, right? So you see, I'm writing it in comments. Previously, we were doing this thing. Okay, similarly, we were saying P of 1 is address of C2. So what you see in the comments is what we were doing previously, that first create an object and then copy the address. But as I told you, we were not using C1 and C2 later anywhere in the program. We are always using P. So you see, it is pretty useless to create these objects. So if you want to avoid them, what you can do is you can use dynamic memory allocation with the keyword new, which will create an object and give you the address of that object. And that address you are storing in a pointer, but be careful, the pointer is to the base class, right? So when we are doing polymorphism, mostly, although if you do the previous one, that is correct, okay, there's no problem with that. But again, if you want to follow good programming practices, I would recommend you that instead of creating an object and copying the address, it's better that you directly use the keyword new and copy the address in the pointer directly. Okay, so instead of having 2 steps, we are doing that in a single step. And of course later in the program you are always using P, so there is no problem. Okay, so this is what was when we say that instead of taking a single pointer, you can take an array of pointer. This is the new thing that we have seen in the last 10 minutes. The second I have recommended you is that instead of first creating an object and then copying the address, you can directly use the keyword new and you can create an object using dynamic memory allocation, right? So now if you have any comments from this, please let me know. Then we see a different example of polymorphism. Okay, the previous example that we had seen, you see, it is you cannot relate it with anything in the real world, right? So I'll now do a different example, which will actually help you better understand that why polymorphism is useful. Okay, so this time we'll do a relatively meaningful example because in the first example, the focus was that you understand the syntax and concept, and now we are in a position to see some example which actually shows you the advantage of polymorphism, right? So what we'll do is we'll make a class shape, okay, and we'll have two child classes, maybe a rectangle and a circle. Both are shapes, okay. Now you see what we want to do. Maybe we want to compute the area of a shape, we want to compute the parameter of a shape, and so on. Okay, similarly we want that maybe there is a function input in which we can enter data. Okay, so now you see we want this from both the shapes, that whether the shape is a rectangle or a circle, I should be able to input, I should be able to compute parameter, I should be able to compute area, right? So now what we do is, if we want to do it with polymorphism, what we do is we make a parent class shape, and all the functions on which we want polymorphism, we'll make them virtual in the shape class, okay? And then we'll override them in rectangle and circle class. So when I'll override the area function in rectangle, so area of rectangle has a different formula, which is length into width. Area of circle has a different formula, which is I think pi r square, okay? So now you see, previously we were doing just C out. Okay, now we'll not be doing C out, but the when we say area, we have a different formula to compute the area of every shape. Okay, so now this example would be more, you can say, easy for you to follow, because now we have some proper implementation within the child classes. Okay, so let's come here and let me write the program on the compiler so that we can see it in a clean way. Okay, so what we do, we start with our class shape. These are class shape. Okay, within this shape I don't need any data, because you see we will never create an object of shape, we'll always create object of the child class. Okay, so maybe I put three function in this void input. Okay, and since I want polymorphism, so what I do, I make this a virtual function in the parent class. Okay, and you don't need, I'm just leaving its body empty, because anyways this function will never be called, right? You see, when we'll do override it, so the function in the child class will actually be called, so that's why I have left its body empty. Similarly, I make a function area, and I make a function parameter. Now you see the shape class has three functions and all three are virtual function, but it is perfectly legal to have a function which is not virtual, as someone was asking, right? Means you can have three virtual functions, one regular function, that is perfectly legal, right? But since we don't need it, so I'm getting rid of it. Okay, so this is a shape class, input, area, and parameter. Now let me make rectangle class. Rectangle, call it rect. Okay, now what is the data of a rectangle class? Sorry, I need to make it a child of shape, so I write shape here. Okay, now the data of a rectangle is that we have length and we have width. Okay, and now we can have a constructor in this class, right? So we say length gets this value, width gets this value. Okay, so this is the constructor. Length class, two data, sorry, rectangle class, two data members, length and width, right? Now what I need to do, I need to override all the virtual functions which were in the parent class. It means now I will provide the body of this function input. Okay. Similarly, I will provide the body of the function area, and I will provide the body of the function parameter. Okay. Now for the input function, we know rectangle has two data members, length and width. So we can ask the user to enter length. and we can ask the user to enter width. Okay, now what is the area of rectangle? Area of rectangle we know is length into width, right? And similarly, the parameter of rectangle is 2 times length plus width. Okay, so let me just make it a bit compact so that you can see maximum text on the screen. Okay, so now you see this is your rectangle class. We have input function, area function, parameter function. Okay, so we have overridden the 3 functions. We also have a constructor. If you want any other function in the rectangle class, that is also okay. There's no problem with that. Okay, now what we do is we make the second child class. What was the second child class? Circle. Circle is also a shape, so we derive it from shape. Okay, now you see the data of circle is different from the data of rectangle. So now what would be the data of circle? It would be radius. And similarly, it will have a different constructor. Okay, now just like we have these 3 functions, input, area, and parameter in the rectangle class, I will have the same functions in the circle class, but now you see they will have a different body because there is a different formula to compute area and parameter of a circle as compared to a rectangle. So first I write this function void input. Even input is different because for a rectangle you input something else, you input length and width. But if it's a circle, you need to input radius. Okay, so here I will write enter radius. Similarly, you write float area. So you say return pi r square. So this is pi, this is r, this is r. Okay, so we have, you see now a different implementation of area function. And similarly, we can write float perimeter. So the parameter of a circle is 2 pi r. So 2 into pi into r. Okay. So now you see we have similarly, if you want, you can make a display function, right? The display function of the circle class will display radius, while the display function of a rectangle class it will display length and width, right? But we are doing it with only 3 functions, but of course you can add more function, like display function can also be virtual because rectangle will display something else and circle will display something else, right? But anyways, I'm not making it. Okay, I'm just going to the main now. Okay, now you see in the main, now we need to do something better than what we have been doing previously. So what I do is I take a pointer to the parent class. Okay, what was the parent class? Shape. So I'm taking a pointer to shape. But you see, maybe one pointer is not a good idea. So let me take 10 pointers. Okay. And just to make it a little bit more close to real world scenario, we will give user the choice. Okay. So I'm taking character choice and I'm taking character because I'll be asking user what you want. And I'm taking an integer which I'm initializing to 0. Okay. So what we'll do is we'll be using a do while loop where just assume the scenario which I told you, that students or attendees are coming to you for registration. So you don't know in advance that how many candidates will come, right? So maybe you can use a do while loop like this. Okay. And here you can write while, and at the end of the loop, you can ask the user, do you want to continue, right? And say in choice. Okay, so this is the traditional way that you use a do while loop, right? Maybe you must have seen it in the first course on programming, that this loop will keep on executing. Every time it arrives at the end, it will ask you if you want to continue. So if you press a Y, the loop will continue. If you press something else, the loop will terminate, right? So why we are doing it? Because we are trying to make it as close as possible to the way things happen in real world, right? Okay, now what we want to do, we want to ask the user whether you want to make an object of circle or rectangle, right? So we write enter maybe C for circle and R for. Okay, so we are saying that, okay, if you want to create an object of circle, you press C. If you want to create an object of rectangle, you press R. Okay, and then we take C in shape choice. Okay, so user will enter a character. Okay, and that character will go to shape choice, right? So now if we say if shape choice is C, then what we need to do? We need to create an object of circle. So I will write new circle. Okay, just like we were doing. Why I'm using n here, right? Because n is 0, and I will, at the end of the loop, I will write n plus plus, because I don't know in advance how many objects would be there, right? If I know in advance, then of course I can use a for loop. Since I don't know how many objects the user wants to create, then that's why I'm using this n, which is 0. Okay. Okay, else if the user enters R, okay, I'm assuming user will not enter an invalid value. Okay, you can check. If user is C, you create circle. If it is R, you create rectangle. If it is something else, you give an error to the user that please enter C or R, right? But I'm assuming that user will not enter an invalid value, so I'm saying P of n means if it is not C, I'm assuming it is R. Okay, rectangle. Okay, now you see, if the user has entered C, we'll create a circle. If the user enters R, you can check with if, but I'm not doing it. You can create a rectangle. Okay. Now what I will do here, you will write P of n arrow input. Now you see, now you will see the advantage of polymorphism. Once the object is created, now you are writing P of n arrow input. Okay. Now you don't care. The program will automatically handle if the user created an object of circle. Input was a virtual function. So this input will be called for circle because this P will have address of circle. If the user created an object of rectangle, the input function will be called for rectangle. Why? Because then P will have address of rectangle. Now you see, this is the statement which is actually showing you polymorphism. That you are writing one single statement where you are calling the input function, but which input function is called, it depends on the address which is in P. Okay, if you created an object of circle, it will be called for circle, which will ask you to enter radius. If you make an object of rectangle, it will call the input function of rectangle, which will ask you to enter, you can say, length and width. Okay, and now once you have entered all the data, okay, suppose we want to print the area. So I will write for int I equals 0, I less than n, I plus plus. Okay. Now what we do, we say see out area of shape. Okay. And what is that? P of I. Now you see, in whatever order the user has created the objects, suppose user created 10 objects, right? So when you call P of I of area, now you don't need to worry whether it is area of circle or it is area of rectangle. Whatever address is in P, the area function of that object would be called. If P is having address of circle, it will show you area of circle, otherwise it will show you area of rectangle. And then the same thing you can do is for the parameter function. Okay, so now you see, I did not take care. I hope there are no errors in this program. So let me just try. Okay, now you see it is saying enter C for circle and R for rectangle. So I enter C. Now you see, when I enter C, what happened? It created an object of circle. And when you write P of an input, now you have two input function. Okay, you see, this input function is saying enter radius because it is in the circle class. This input function is saying enter length and width. So, and there's an input function in the shape class which is empty because we don't need it, right? Because we always call the child class function, so there is no body. So since I created an object of circle, so it is asking me to enter radius. Okay, so I enter radius, say, which is 5. Now it is asking me, do you want to continue? I say yes. Okay. Now what happens? It will again ask me enter C for circle and R for rectangle. Now I will say R. Okay, when I create an object of rectangle, now you see when you write P of an arrow input, now it is not asking me for radius. Now it is asking me for length and width because I created an object of rectangle. So I enter length, which is 2. I enter width, say, which is 4. Okay, so again it will ask me if I want to continue. Let me just make it bigger. Yeah, so say okay, 2 objects are sufficient, I don't want to continue. I enter no. Now you see it is saying area and parameter. So these are area and parameter of the circle which I created, which have a different formula, and this is area and parameter of the rectangle, right? You can compute 2 into 4 is 8. So you see 4 into 2 is 8. Similarly, if the parameter is 4 plus 2, which is 6, 6 into 2 is 12, so the parameter is 12. Now you see the advantage that here whatever address is in P, that area and parameter function is called. We don't care in what order we created the object, right? The program is automatically taking care of it. On the other hand, if we are not doing polymorphism, then you see you will have different object names. You will be using if else, and then you will be calling the appropriate function. Now our program is very clean. Whenever I need to input something, I call the input function. Okay. Now you can correlate it with the form example that I was giving you, right? That if the students are coming, so this input is like a form. So for every type of attendee there would be a different form, right? So the same is happening here. When I'm creating circle object, I need to input different data. When I create the rectangle object, I need to enter length and width. I don't need to enter radius, right? And this is demonstrated by this you can say statement where I am calling just one function input. It will automatically figure out that I need to call input of circle or rectangle, right? By looking at the address which is in P. Again, the same thing concept explained through area and parameter function, that once we have entered all the data, now I need to print data. I need to print area, parameter, anything. Now I don't need to worry that first was circle, then there was two rectangle, then another circle, right? The program automatically is keeping track of the addresses. So when you write P arrow area, P arrow parameter, it will simply see what address is in P, and then it will call the appropriate function, right? So I think this example will clear some of your queries related to polymorphism, right? I have this example in the lecture slides as well, so don't worry. This is available in lecture slides as well, so that you can practice it, right? Now, if we have some queries related to this particular example, we can discuss those. Okay, now we'll discuss few minor things before concluding today's session, right? I understand it was a heavy session, right? So, but I have tried to keep the pace slow so that you get the idea. Now, let's discuss few things that what will happen if we do this and that, right? Something like that. Okay. The first thing is that you see, um, okay, suppose I am overriding these functions in the child classes. But someone can say, what happens if I don't override a function? For example, if I don't override this input function in the rectangle class, then what will happen? You see, this is okay. This can happen. If I'm not overriding it, then what will happen? So in that case, if you are not overriding a function, what will happen? This parent class function will become a part of rectangle class. Okay, so if you are not overriding a function, what will happen? When you will call it, it will call the input function of the parent class, right? For example, I can write here something cout just to test. Okay, now although you will not do it, okay, but just in case, because syntax allows it, so it is possible that someone says, okay, I'm not overriding this function, I'm overriding area and parameter, but I'm not overriding input. Okay, I have commented it out. So in that case, what I'm trying to tell you is that the program will not give you any error. This is okay. If you have not overridden it, then what will happen? It will simply use the parent class version, because when you don't do overriding, then this function will become a part of the child class. Okay, so this will be called. But of course, when you are writing a program, you should be careful that you are overriding all the function. But the idea is to tell you that just in case if you don't do it, the program will still work. The only thing is that it will then call the function of the parent class, right? Because it will not find it in the child class. Okay, anyways, I'm just reverting it back to this. Okay, one last discussion for today, which will actually build the preamble for tomorrow. That you see, you must have noticed that when you are doing polymorphism, you are always making object of child class, right? You will never make an object of shape. Okay, either you make rectangle or circle, because shape itself is not something meaningful, right? If this example does not help you understand, then maybe I can I can give a different example. That normally whenever we are doing inheritance, I always give you this example of accounts. Okay, that suppose a bank is managing accounts, so you need to design a system for the bank. So normally there are two types of account. One is called saving account. Okay, and the second one is called current account. Okay, so you see every account has a balance, every account has an account title, address of account holder, but saving account has some different attribute. Like in saving account, you have to maintain a minimum balance. Okay, you cannot withdraw everything and then you get some profit. In current account, there is no profit. Okay, but there's also no limit. So these are two different types of account that you commonly see in the banks, right? Now, if you are making a program that can handle accounts in C++, so definitely it makes sense that you will do inheritance, right? Whatever are the common functions and the common attributes you will put in the parent class, which will be account. And then whatever are the specific attributes and functions of these two types, you will put them in the child classes, right? Okay. Now you see, when someone comes to you, you are a bank manager and someone comes to you that I want to open an account. Okay. So you will say, whether you want to open a savings account or a current account. Okay. So whenever you will create an object, either it is saving account or current account, you will never create an object of account, right? Because account itself is nothing. There are only two types of account, saving or current. So if a customer is coming, so you will ask, okay, you want saving account? Yes, you will create an object of this class. If he says, I want current account, you will create an object of current account. But you see, you can think that there is never a situation when you create an object of account. Why? Because this account class was not meant to be instantiated. You did not make it because you wanted to create its objects. The objective of this account class is that you could do inheritance, you could reuse the code, and you could actually do polymorphism if you like, right? This class was never meant for object creation, because account is either saving account or current account. There's nothing which is called simple account, only account, right? This was your implementation. So it means that we should never be allow user to create objects of this class. And the same example is valid for shape. If you have a shape, okay, so either you create a rectangle or a circle or a triangle or a square or anything, but you cannot just create a shape. If I ask you draw a shape, it is not very meaningful, right? I should ask you draw a circle or a rectangle or a triangle or something. So it means we will never create object of shape class, we will create object of one of the child class. Okay, so in some cases, if you want to ensure that no one is able to make object of shape class, right? In this case, user can make object, right? Although you will never do, but still, if someone is making, this will not give you an error. For example, I can write here shape s. That is okay, right? It is not giving me any error. Similarly, if you have account class, you can write account a. Okay, so if you don't want to allow it, okay, because as I keep telling you that you are writing classes, maybe someone else is using it, then what you can do is you can make your parent class a special type of class which is called an abstract class. Okay, I'll give you details tomorrow, but I'm just telling you that if you want to stop users from creating objects of this class, then you can make this class an abstract class. So what is an abstract class? An abstract class is a class for which you cannot create an object. If you will try to create an object, the program will not compile, it will give you an error, right? How do we do that? That we'll see tomorrow. Okay, I'm not telling you, I'm just telling you what is an abstract class and why we need it. We need it because in some situations we don't want user to create the object of the parent class, right? As I have explained to you through these examples. So if you want to make sure, if you want to restrict that no one should be able to create objects of a certain class, then C++, there is a provision that you can make it an abstract class. If a class is abstract class, you can derive other classes from it, but you cannot create objects of the parent class, right? So this is what is it, how we do it, that we'll see tomorrow, right? So I'll conclude for today. If you have any quick comments or queries, we can discuss and then we can